So, yeah, I canceled class for Monday and Friday because I'm at the LPSC, Lunar Planetary Science Conference in Houston, Texas. Um, so I've been watching stuff on Mars, about Mars. So let me share a screen here and clean this up. So week 8, there's nothing to turn in, but week 9, 10, and 11, we move to the advanced top live trainings. And the first one of these is not due till the 27th, and then they come 1 week after that. And so I wanted to talk about them today because we have this whole break coming up, and a lot of you might want to get started on these because these are harder than the ones that we've been doing so far for a number of reasons, mainly that they do a lot of scripting. You're expected to complete 3 of your choosing. I'll show you the list here in a minute. It's not 3 a week, but it's 3 total. I recommend skimming through the videos before you commit. And I am open to suggestions. If you find a topic that I haven't put on the list and you want to try it, email me with a link and I'll consider it. The topics that I've identified include a number of scripting ones, persistence and saving loading data, object pooling, scriptable objects, sound effects, AI, particles, a messaging system, fun with lasers, fun with explosions, cinematic composition, putting it all together, the post-processing stack for manipulating your images, shooting with raycast, sound effects, character animation, and more. All of these are my suggestions for live trainings that you'll do for the week 9, 10, and 11. And as I said, I'm open to suggestions. I went through the list last night, and Unity in its wisdom has deprecated a number of these. So you'll see they're crossed out. They're no longer available, and I've updated the schedule on the Brightspace to reflect this. But if you've downloaded the schedule, you may want to re-download it. Okay, so it's not required, but if you can incorporate your advanced topic into your final project, that's a good thing. And we're going to do this very differently from the way we've done the homeworks up till now. Up till now, you've been handing in zipped up full game folders. But what we're going to do here is export packages. And most of you have downloaded something from the asset store, and the stuff that you download from the asset store are packages. And we're going to learn how to make these packages so that someone else can import them into their Unity project. I have a couple of design criteria here for these packages. One, all of the material that you create for the package should be in a single folder. And that folder should have your name on it and the topic that you've done. So, for example, over here in my coroutines project, I have a folder, Fast Took Coroutines, that contains all of the stuff that I did for this coroutine example. This folder should itself be organized and have things like folders for scenes, folders for materials, scripts, textures, documentation, prefabs, anything that you have to make for your advanced topic. And this all resides here in this one folder with your name and the topic on it. Now, we often use assets from other places, things like the standard assets, various materials, other scenes, scripts, and so forth. And you don't have to move them into your folder. In particular, don't move standard assets because they all have namespaces that require that they be in particular places. You can leave them alone and let Unity figure out what you need to export. Another important fact of this is because everyone's using a different version of Unity, and I have to import this into the correct version of Unity, your package name should include the version of Unity that you're using. So it would, a suggested name for your package is your name, the topic that you've done, and the version of Unity that you're using. Another thing is you don't need to zip up packages. They're already zipped. They're already compressed. So all you need to do is turn in a link to your package on the Google Drive, and I can download that and include it without having to zip it up. So don't zip it. We include in the package documentation that explains to the user who obtains your package, in this case me, how to set up and use what's contained. This can be a readme.txt or a PDF or a Word doc, any kind of document. In addition, I want a one-page document that describes your experience with the live training, what it was about, what you learned, the nature of the tool, and be critical. If you found it to be stupid, say so. And this should also be included in the documentation folder. So here I've got PDFs for what goes on in here. There should be a demo scene, and it should be lightweight. This is not something where we're trying to include massive folders of assets. If your tool is something simple like a gun, a scene with a player with the gun mounted on it, and a target to shoot at is all you need. You don't need terrains and trees and water and all this other stuff. It should be lightweight. These packages should not be big. We're not going to be uploading gigabytes with this project. These should be small, tens to 100 megabytes. The demo scene can be very simple. As I said, a plain, a light, a character in your product. And they should be completely assembled, and the object that you've built should be a prefab. Some of the assignments make scripts, and you don't have to prefab them. I should be able to open an empty game, Unity game, import your package, have the demo scene just work, and be able to make a simple scene of my own and drop your prefabs into it, and with very minor fiddling, which you would describe in detail in the documentation, have it work. You must do this yourself. You must test this. Once you export a package, you need to open an empty game object, a game folder, import it, and see if it works. You've got to test it. If it doesn't work for me, the grade will reflect that. Good examples are the detonator framework package that some of you have played with. The terrain toolkit package is another one where everything that it uses is all contained in one folder, and it's all organized. Think of this as preparing an asset that you yourself might want to sell on the asset store. This is sellable products. So the simplest version of this is you select this named folder that you've put all your stuff in. You don't have to select these other folders because Unity will do it for you. And we just pull down the asset export package, and it then goes and picks up everything that is necessary for that folder, the scenes that are contained in it, the prefabs, materials, and everything. This little check mark, include dependencies, means that it will pick up stuff that we don't use, things that we don't, or things that we use. So this is picking up things like the standard assets, grass hill textures that I used, but it's not picking up all the other cruft that is in the standard assets. It's only picking up that which is necessary for my scenes. And I press export here, and it asks for a location, and it makes a package. Now, there's one real gotcha here, and that's if you've got any custom layers. So here I have a custom layer, and so if I have any custom input settings, like if I've fiddled with the Fire 1 button or something like that, or if I've got transitions among scenes, if I have build settings, anything custom that gets stored in the project settings folder. And the project settings folder is outside, where are we here? The project settings is stored here in this folder. This has the build settings, and it has all the other stuff that the tag manager, if we have custom tags. And so if you have anything custom, you have to include in your submission the package and the project settings. And if you happen to use any added packages from the package manager, things like Cinemachine or the terrain tools, these reside in the packages folder in this JSON. And so you would have to include them. However, if you don't have any of these custom things, you can just do the straight export and not fiddle. But if there are any custom tags, layers, build settings, you must include the project settings. If there are any custom packages from the package manager, you must include the packages. And so, and you must include very clear instructions for me that tell me that I have to copy them into the new game folder or things won't work. So, and of course, if there are no custom tags, input settings, layers, build settings, or Unity packages, you can simply do the assets export and be done with it. So quickly, I'll stop sharing here and see if there are any questions about the advanced topics, assignments 9, 10, and 11 that come later in the month here. No? Okay. So back to sharing screen here. I'm done with this now. So there's a lot to do here. Let me close this. So if you watch the Monday videos, the pre-recorded ones, we talked about some C# programming details. We had variables, functions, and classes, sometimes called properties, methods, and data types. And we had the standard data types, integer, float, and Boolean. Unity has other data types. For instance, the vector 3. And the vector 3 has 3 values, x, y, and z. And we make a vector 3 by specifying the type, the name of the variable, and the new word, and the vector 3 with its x, y, and z values. This is the constructor for this struct. It's actually a struct that represents positions, points in space, or directed line segments, vectors that have magnitudes in the x, y, and z directions. Now, as a struct, it has a number of variables. Some of these include things like pos.x, .y, and .z. These are the x, y, and z components of my POS vector 3, 1, 2, and 3. We can also use the square bracket form to access them as if they were an array. If we do the POS.normalized, this will yield a vector that's in the same direction, but has been reduced to having a unit length. And we have methods like magnitude and square magnitude that yield a float that is the length or length squared of our vector. So all of these are properties of the vector 3 class. A number of static properties are the 0, 1, forward, back, up, down, right, and left vector 3s. The 0 is a vector with all 0 components. The 1 is a vector with all 1 components. Forward is in the z direction, back is in the negative z, up is in the y, down is in the negative y, and right is in the x, and left is in the minus x. So these are kind of shortcuts so that you don't have to define a new vector 3, 0, 0, 0. You can just use vector 3.0. There are a ton of methods. You can find these in the scripting manual under the help menu for Unity. There are things like angle, which returns the angle between two vectors. There's the cross product. There's the distance between 2 points. There's the dot product of 2 vectors. There's lerp. We'll talk about that later. And other things that these methods that do something to our vector. So, and these all have vector type arguments. And I'll let you read about them. In general, most of these have code fragment samples that tell you how to use each of the different methods. So let's go on here and make the world's simplest controller. And I'm going to use the horizontal and vertical axes. We've played with these with the block shooter, and I'm going to use the transform position to position this thing, and I'm going to do this with the horizontal and vertical axes that are the left and right arrow and the AD keys, and the up and down arrow and the W and S keys. And here in this test axes scene, I draw your attention to this little script, test axes. Let me turn off debug here for the time being. And I've added a little bit to it so that we can see the value of the axes in a vector 2. And if I play this thing, please watch the values of the axes here in the inspector. As I press the left arrow key, the x-axis goes to -1. The axes do not go instantly to 1, they go gradually to 1. And we can we can actually press two of them at the same time. I'm pressing up and left arrow key, and it's moving my little character around. That's one of the advantages of the axes as opposed to the button or the key, is you can have more than one pressed at the same time. The input class has a lot of different things to it. Get axis, we have a number of default axes that are already defined for us, horizontal and vertical, that map to the WASD and the arrow keys. We also have mouse deltas. We have the fire 1, 2, and 3 buttons that map to Control, Alt, and Command, as well as the 3 mouse buttons. And we can look at the input manager to see what all of these things are. In our project settings here, the input manager, here are all the predefined axes. A lot of these down here are for joysticks and other kinds of devices. But if I look here at the horizontal, it has a negative button. That's the one that's going to go to -1, and it has a positive button, which is the one that goes to +1, and it has alternative plus and minus, or negative and positive buttons, A and D, and then some other stuff that adjusts how sensitive it is and how quickly it returns to 0. And the fire 1 is the left control and the mouse 0. It doesn't have a negative button. It only goes to +1. And it has very strong gravity and other settings. And you can customize and change these yourself, and you can make new axes of your own creation here. You can make your own axes. Some of the trainings suggest that you do this. So the input class, the get axis, because it has this nice feature of going gradually from 0 to 1, not instantaneously to plus or minus 1, we use this for movement behavior. When we want to drive our characters around, we do this because the speeds increase gradually and they don't instantaneously go to a particular value. The get button act on the axes, but instead of returning 0 to 1 or plus or minus 1, they return Boolean values. So a get button on the horizontal axis would tell me true or false whether the A and D keys had been pressed. An important thing when we get to physics is that inputs are done in the update function. You should only put input in the update function, not in the fixed update where physics is done. So other methods, other properties of the input class, there's a read-only mouse position that tells you where the mouse is all the time. There's any key that a lot of you played with in your assignment 7. There's the get axis that I mentioned. There's get button. I think that should be just get button. But there's probably also a get mouse button that returns true when the specific button is either held, that's the get button. When it's pressed, that's the get button down. And when it's released, that's the get button up. There's get key and get key down and up. This is true again when the key is held, when it's pressed, or when it's released. And when we ask for a key, we should ask for it via its key code, which is the key code.r. Some of you did it this way with a quote around the key. That works, but this is better to use a key code.r. So let's go on and improve our little controller so that it doesn't just zip back and forth here. Actually, I missed one someplace here. I missed controller A. controller A. Here's controller A, which is going to use the transform translate. I'm going to show you that in a second. That has an X, Y, and Z values. And I'm just going to directly put the input get axis horizontal in for the X and the input get axis vertical for the Z. And I'm putting 0 in for the Y, so it's not going to move vertically. And when I play this, what I see is this thing moving rather quickly because the axis goes immediately, well, gradually to 1, and every frame we're adding 1 meter per frame to the object's position. So that's one way to do this. But this version B is a little better. Version B has now an exposed variable, the speed. And this is a float, and I've got a default value of 5. And note that floats in Unity must have the F after them. If you leave off the F, you get a compile error. And here I'm going to catch into X horizontal, scaled by time delta time, and that's speed. And the Z is going to be the vertical, scaled by time delta time, and the speed. Now, the reason I'm doing the time delta time, which is, I'll show you in a second, is the time that the last frame took to render, means that I will be now moving speed per second as opposed to speed per frame. If I didn't have this time delta time here, every time I went through a frame in the update function, one display of my world, I would be moving speed times the horizontal axis in that direction. And by multiplying it by time delta time, which is whatever time the last frame took to render, 0.01 second, I'm now going to move a fixed amount. And so now my little controller B here, the little A player here, has a simple move script on it with an exposed variable speed. And if I run this, I can drive this little character around in the world, and it moves at 5 meters per second. And the nice thing about this is I can change the speed here to 10 meters per second. And now my little character moves faster. And if I want maybe 15, the character moves faster still. Notice any changes that I make here while the game is running disappear when I stop. It goes back to whatever was there originally. So you can make adjustments while the game is playing, but they're not persistent. So that time class, one that we sometimes use is time.time, which is the time since the game loaded, since the beginning. So if you need a clock that keeps track of how long the game's been playing, time.time will tell you those times. Time.fixedTime is the time of the physics frames. These physics frames come at regular intervals. And the time scale is how fast time is passing in the game. By default, this is 1, and time passes at normal times. But if you set the time scale to 0.5, then it runs half as fast. These are all things that you can set in the project settings. Well, timescale you can set in the project settings, but these are accessible in scripting too, so that we can, in the game, change the time scale so we can like have a slow-mo scene where it slows down during the explosion. Now, I showed you that we use the transform class up above with that method translate. But there are a lot of properties. There's position, which is the position of the transform in world space. There's local position, which is the position of the transform relative to its parent. So if our object is the child of some object, local position will give its position in X, Y, and Z world space coordinates, but relative to the parent. There's Euler angles, which gives kind of the rotation of our object. And there's local Euler angles relative to the parent. There's right, up, and forward, which is a unit vector in the X, Y, and Z local coordinates of our object, but converted into world coordinates. So if our object is rotated around and we do right, which is out to the right-hand side in the X direction of our object, that unit vector will reflect the world coordinates of that direction. There's rotation, which is a quaternion. We'll talk more about quaternions later. It's a way of describing the orientation of a transform. It's similar to Euler angles that does the degrees around X, Y, and Z axis, but it's better, and we'll talk about it later. And there's also local rotation relative to parent. There is no dot scale, but there is a dot local scale. If you're the top of a hierarchy of objects, local scale is relative to the world, so that's fine. The world is the ultimate parent. We can find the parent of our transform. If it's a child, the parent will tell you the next one up in the hierarchy. Root will tell you the one all the way at the top of the hierarchy. Child count will tell you how many children you have, and there's world to local matrix and local to world matrix. We won't use those very much. So that translate method that I used with the controller, as with many of Unity's methods, it's overloaded. It takes different arguments and it recognizes them in context. So the translate can either take a vector 3, a vector of X, Y, and Z values, or it can take 3 floats, X, Y, and Z values that you want it to translate. It has this optional argument, space, the relative to space. And space is either space.self, in which case the translation that goes on is in the local coordinates of the object, the transform. So, or it's space.world, in which case the translate is in the absolute coordinates X, Y, and Z of the world. And there is the option to actually put another object's transform in for the relative to space, in which case the translate is relative to this other object. You might want to use this if you're like blowing things up and you're applying forces to objects and pushing them away from the explosion with the translate. The space might be the other object's transform or the camera or something else. If we leave it off, which we do most of the time, it's relative to the self. We used that in simple move B. I did transform translate, the X, the horizontal axis, the Z, the vertical axis, and the Y, the 0 axis. The alternate form, I could say I want my object to move forward by some speed. So I translate with a vector 3 forward, time dot delta time times speed. This is going to work because vector 3 forward is the vector 0, 0, 1. But because the space is the self, it's going to move along the object's z-axis in the forward direction. So this will translate my character forward along that its own z-axis. We also have rotate, and rotate is also overloaded. It'll take a vector 3 of angles, or it'll take X, Y, Z 3 float angles. And this rotates our object about in either the self or the world space, or another object's transform. There's also a very powerful transform rotate around, and this takes a point in space and an axis, a direction, and it rotates by an angle around that axis. That's a very powerful one. So in simple move C, I now have two exposed variables, my forward speed and my rotation speed. Rotation speed here is going to be 25 degrees per second. And I'm using T from horizontal axis, that's time delta time rotation speed, and S, that's vertical axis, time delta time times forward speed. And I'm going to translate by S, that's the vertical up and down arrow keys, and I'm going to rotate about the Y axis by S, I've got that backwards, by T, the horizontal axis. And so this one, a simple controller C, I now have this little character that I can press the up arrow and it goes forward. And I can press the right arrow and it turns to the right. And so I'm moving forward or backward, I'm rotating. And again, the axes, the advantage is I can press two buttons at the same time and have them respond. So that's a completely different way of doing a controller, one more like we would drive around the world. Now, back when we were playing with lerps and lights, we used the look at method of the transform, and the look at is also overloaded. It takes as argument either a transform that it will look at in space, or a vector 3 position that it will look at. And what look at does is it rotates the object, the transform, so that its z-axis, its forward axis, points towards the target, which can be a transform or a point in space. And it has this optional world up vector, which by default is the y-axis. When you point something at an object, you also have to specify how you're going to rotate, what direction is up in that view. And by default, the y-axis is up. So we use this for aligning cameras. We have a third-person camera that looks at the character. And we wrote a little look at script called follow. We have a target transform that we're going to look at. And I've included a little debug here that draws a line from the target position to the transform, the object that the script is on. And if I go to look at here, I've put the look at on the spotlight, so it's on the light. So this is going to orient my light to look at the object. And the target here is my little player that I can drive around in the scene. And here in the scene view, if I turn on debug, it's going to draw that line. And if I turn on debug in the game view, if I turn on gizmos in the game view so that I can see these gizmos, I will also see the line in my world. This draw line here goes from one position to another position and a defined color. And this is not something that you would use in a published game. This is a gizmo. Gizmos are only visible in the scene view or the game view if we have gizmos selected. So with this now, I can drive my character around and the light follows me scrupulously, keeping the spotlight on my little character as I drive around the scene. Couple of obscure ones. There's transform direction and transform points. Transform directions takes a vector and converts it from local coordinates to world coordinates, and transform point does the same thing with the position, and they're inverses of these. Here's an example from the Unity documentation of transform direction. This would apply a force in the camera's relative right direction. So this would push the rigid body to the right of the camera. Here's another way of doing it that doesn't use that, just use the camera dot right as opposed to this transform direction. An example that I have here is instantiating an object 2 meters to the right. So the position that I want to instantiate this object is transform vector right times 2, and that position is where I instantiate my object. So here in this little example, if I press, I think it's the P key, it instantiates, whoops. If it instantiates a little particle effect here to the right, and if I drive my character around, you'll see that I'm making objects to the right of my little character here as I drive around. There are alternative ways to do this as well. We can use that transform right, in which case we put it at the position plus this transform to the right. And this does the same thing either way. You can test if you're the child. This indicates whether the transform is a child of a specific other object. So you can test to see if you're the child of something. Returns true if it is, and false if it's not. Now, in the player status, we did some communicating among scripts, and we can do this through components using the get component function. We can access exposed variables in other scripts. We can access public functions in other scripts, and we can locate objects by name or by tag. So in the look at example, I had the follow script that tracked the player. It had an exposed variable target, but I'm going to add to the spotlight the switch A script. This is not the same as the follow script, but it's on the same object. It's on the spotlight. On the spotlight, we have this switch A component. And I'm setting this up so that when I press the jump button, which is the space bar, I'm going to reach out to the follow script using get component, and I'm going to access its exposed variable .target, and I'm going to set it to what I want to switch to, which is my own exposed variable switch to target. So here, our follow is originally following the player. The switch A script wants me to switch to the sphere. That's this little ball over here. And if you watch what happens in the inspector here, when I play this and I press the space bar, it's going to switch the follow script to the sphere. So that reached out, switch A reached out to the follow script using get component, and it accessed its exposed variable target, and it set it to what it wanted. So these exposed variables can be set by other scripts. We can read it out as well. So switch B is a slight modification so that when I release the jump, it reverts to the original. And so now here I have a public switch to target, what I want to switch to, and I have a private that doesn't show in the inspector, the original target. And in the awake function, I'm reaching out to the follow script and catching a copy of its target, what the follow script is originally set to. And then in the update function, when I press the jump button, it sets again, get component follow and sets the target to switch to target. And if the jump button is not pressed, it sets it back to the original target. And so now with my switch B set up here, where on the spotlight, I now have the switch B. And here's a little trick I want to show you. If I put this in debug mode, I'm able to see the private variables, and I can't change them. They're not accessible, but I can see them. And so if I run this now, you'll see that in the original target here, it gets the A player. And when I press spacebar, it switches my player to the sphere, my target to the sphere, and when I release it, it goes back to A player. So I now can switch back and forth here among between the target and myself. So all very cool. So we had the get button, which tests, is it pressed? It's a Boolean. We have get button down, which tests when it's a single event when the button is pressed, and the get button up, which is when the button is released. So I could rewrite that function or that script to be a lot more efficient by triggering on the get down event and the get up event, press and release, make it much more efficient. That is definitely not an efficient version of that script. And I remind you that we're using axes. The jump is an axis, and we're using the get button, which returns Booleans instead of the 0 to 1 values that the get axis returns. An aside about the get components here, these are, we're doing this with the square bracket form, which these are sometimes called generic forms, where we're specifying the type. Notice that there's empty round brackets here that we're not using. And that means we can do this kind of tricky thing where we say var object, and it will automatically infer the type from the get component rigid body. This is instead of doing something where we say rigid body RB, specify its type, get component type of rigid body, which is the full-blown version of this. But this form, where we can say var hinge get object, game object get component hinge joint, will infer that hinge is of type. Here are the other more rigorous forms where we're doing it as a hinge joint, or doing it with type of, or doing it with string. Any of these methods also work, but this of course is the easy way to do it. Get component has a lot of different variants. Get component does it on the game object that you get component on. It doesn't have to be the game object your script is on. It can be other game objects. But you can also do get component in children or get component in parents. So this will go down a hierarchy and find the searched for component in any of the children. If more than one exists, it'll return one of them. You don't know which one. Get components, where we add an S, will return an array of all the components. And we can do components in children and components in parents. And I believe we looked at this when we were playing with rag dolls. I said that if you had a rag doll, you could go through all the rigid bodies in the rag doll and set them to be as kinematic, so that the animations could control your character. And then when you killed your character, you could go through all those rigid bodies and set is kinematic to false so that your rag doll would fall down. And so here we're doing get components in children of rigid bodies, which is here in the public just so that I can see it, with square brackets, which means it's an array. An array we can access through its index, 0 through number -1. And I still have 30 pages to go with the Unity API, but I'll pick up with that, or I'll post a lecture for Friday, but I'll go through this Monday after the break and pick up with all of this again and continue this on. The Unity API is huge. It's a work of a lifetime. So I'll stop there, stop sharing, and entertain any questions, and remind you all to type your name in chat. And well, someone in chat says, is our next assignment due the 20th? I think it's not, I don't think there's any assignment. Well, there's a reading for assignment 8. I think we are supposed to read about quaternions, but there's nothing to turn in for assignment 8. Assignment 8 is a break from submissions. And so I think the next assignment that requires you to turn something in is assignment 9, which I don't believe is due till the 27th of March. So a good long time. But I will remind you, assignments 9, 10, and 11 are a lot harder than the assignments we've been doing so far. So you might want to get started on them soon. That's kind of why I give you the break, is so that you can get a head start on them. Okay? Any other questions? That answer it, Dave? And he's gone. Okay. I'm going to stop recording.